Okay,
Unless you want me to upload it, I can do that.
you're in charge. Okay, today's the 22nd. Let's go over the test. Let me do that first one again. All right, just to get a record of it. Bring the dx over. Integrate both sides. Okay. Number 2, solve the differential equation. Separate the variables. Integrate each side. Now, we're given an initial condition, namely, we have to contain the point 0, 0, so y is 0 when x is 0. Cosine of 0 is 1. C, therefore, is equal to 1. The answer, y equals the opposite of cosine plus 1. Okay? Oh, okay, if you have work that's essentially correct, but you got it wrong, let me know.
The first one,
What'd you put? What's your answer? Why'd you do that?
because I misread the question.
Because what?
I misread the question.
Solve the differential equation.
I
What's
did
that?
that render.
All right, that's it.
Can we just wait till the end of class to ask you
No, that's not good.
about the partial credit?
Yes, that's not good. I want you to do it as we go along.
Oh, okay.
I don't want to be mobbed by 26 people all at once asking me 2 or 3 different questions. Okay, so what I've done is I put this on a spreadsheet already. Which okay, number 3. Average value, 1 over b minus a, the integral from a to b, f of x dx. So, a is 0, b is 1. The average value, 1 over 1 minus 0, the integral from 0 to 1 of 2x dx. This is 1, the integral of 2x, x squared over 2, the 2's will cancel. Substitute in 1 to get 1, substitute in 0 to get 0. The answer is 1. Okay.
I might have something.
What's that?
I might have something.
Give me a second.
Well, I mean, I do. I originally did the problem and I had it right, and then I second guessed myself with the like u squared there.
Oh, this is right. This is around.
Yeah.
Okay. Okay. Number 4. The average value, 1 over b minus a, 0 to 4, square root of x, 1/4 x to the 3 halves, times 2/3 from 0 to 4. That's 1/6. Okay. Put a 4 to the 3 halves, 4 to the 1 half, 2 cubed, 8. 0 to the 3 halves, 0, 8, 6, 4/3. Number 5. Average value. 1 over b minus a, the integral from 1 to 5, 1 over x dx. It's 1/4 natural log x from 1 to 5, 1/4 natural log 5 minus the natural log of 1, but the natural log of 1 is 0. This is the answer, which makes it an E answer. Because I'm fallible, that's all there is to it, okay? All right?
But I'm on the cloud, would that be extra?
No, it's not. Because then I give it to just about everybody, because virtually everybody missed that. I don't know. Well, I did too, so it's understandable, I guess. So the 1/4 has to be in the front.
I circled it on the paper E, but I wrote it on my paper C, and I actually had it written like that.
So you circled it on the test. I'll come over with you. And you have it on there, but
Yeah, I even wrote it here.
Number 5. Actually, if you wrote natural log 5 over 4 on your test somewhere, which did not answer E for some reason, that would be half credit.
I mean, it's on here.
What?
I mean, it's,
You got natural log 5 over 4?
it's on here, Ben.
Oh, that's a mistake
Yeah,
there.
no, right here is where I made it.
Yeah.
But you did say if it's on there.
It is, it
Class
is.
is a witness.
I agree, I agree. Brendan, that's what you had?
Yeah.
All right. Okay. Anybody else had the natural log of 5 over, no, natural log of 5 over 4 or 1/4? That you had that? But didn't answer E?
Me too. And we all did.
You're gonna ruin this half credit thing for all of us.
All right, that's it. You got it there, Lois?
I had natural log of 5.
Over 4.
The 1/4 was missing.
Oh, well, that's the key. That's the key.
I'm missing I'm missing the 1/4 in front of the 2 over 3x.
Okay, all right, well, that's okay.
I got it on my paper.
What?
You just wrote it, didn't you?
No, I swear to
No,
God.
he didn't. Lewis wouldn't do that. Well, there's no natural law. All right, I can't do it.
I answered it on the paper though.
Let me see. Oh, boy.
I put C.
I'm gonna have Mr. McDonald be a
I put
judge.
C. I put C. Listen, right here, listen.
No, it's 1/4 natural law. 5 is the answer.
And where's the paper?
This one, I got 7. I got this one wrong. Like I wrote, that's what I did. I just like wrote the wrong answer.
Where is it?
This one's 7. This one's the first step. and I
Yeah,
had-
U is X
Is
squared.
that average?
Like I actually took it.
Okay, but I didn't put.
That's not good enough. Sorry.
It didn't exist here.
I don't know, Lewis.
Look at it, Birds. Look at it. Look at it.
I like that. I can't see a natural log 5 and a 1/4 together.
Natural log 5 is on the test, and the 1/4 is on my paper. So you have to combine them. You can't take the work away from the test.
Oh, that's it. That's it. Mr. McDonald, Professor McDonald is the ultimate judge.
Wow.
He's tough. Hey, he's tough. That's the way it is, though. All right, number 6. Thank you, Professor McDonald. 6. First step in evaluating the integral, the first step here is to let u equal x plus 5. By doing that, you have a u to the n form. 7. First step here is to let u equal x squared. By doing that, you have a sine u form. 8. First step here is to get rid of the square root by letting u equal the square root of x plus 1.
Thank you.
Okay, you're welcome. Yeah, we did that problem in class, yes.
Could you have done it without the square root there?
Yes, you can. It is possible to do it as a u equals x plus 1 thing. So you answered none of these because you let u equal x plus 1?
Yes.
Give it to him.
Okay. All right. Okay. 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 Levi. All right, did anybody else do that? I noticed there were quite a few E answers, but if you have on your paper, let u equal x plus 1, I would give you half credit for that. Egg?
Yeah.
We did it in class, and I mentioned at the time that there were 2 ways to do that problem. Let u equal x plus 1 and let u equal the square root. And I preferred let u equal the square root to get rid of the square root that way. And that's what I expect. But if you put E answer and you put U, all right, I'll do that. Yeah, I gave you half credit. 9. The way to do 9 is to divide, do a long division, okay? As long as the degree of the numerator is greater than or equal to the degree of the denominator, do the long division, integrate the remainder, okay? There are other possibilities for some of these, but that's the general way to do that problem. 10. Integrate each. Well, let's take a look. 0 to pi over 4, 2 cosine 2x. This is a cosine u form. U is 2x. The du is 2dx. We have it. We have a 2 right there. So the integral is, okay, cosine u du. U is 2x. The du is 2dx. Integrate cosine, sine. Okay. U is equal to 2x. Substitute in, you get the sine of 2 pi over 4, this is the sine of pi over 2, minus the sine of 0, which is 1. Yeah. Whoa, I'm way off there. Okay, there you go. All right, 11. Okay. The integral, 0 to 1, e to the 3x dx. Multiply, it's e to the u form. U is 3x. Du is 3 dx. Multiplied by 3 and by 1/3. The integral of e to the u is e to the u. So we get 1/3 e, put a 1 in here, cubed, minus e to the first, e to the 0, which is 1. That's the answer. Okay? Okay? 12. The integral, 0 to 1. 1 over x plus 1 dx. 1 over u du form, natural log x plus 1. Natural log of 2 minus the natural log of 1. Natural log of 1 is 0. 13. Integral 0 to 1. 1 over 1 plus x squared. This is inverse tangent. The inverse tangent of 1 minus the inverse tangent of 0. Inverse tangent of 1 is the angle whose tangent is 1. That's 45 degrees, pi over 4 radians. The angle whose tangent is 0 is 0. Pi over 4 is the answer.
For 11,
11? What the heck? That was
I
not two
was
problems.
just browsing here to make sure that I did try.
Let me see it.
I let you react, something went wrong. I couldn't find it.
U equals 3x. See, you integrated the thing instead of taking the derivative here. I can't do it. You went awry right there with that derivative. 14. The integral, 0 to 1. 2x. X squared plus 1. Squared. Cubed, rather. This is a u to the n form. Now, it's possible to do by multiplying the whole thing out, okay, and integrating it term by term, but the way to go is to let u equal x squared plus 1. The du is 2x dx, which you have. Therefore, it's the integral of u cubed du, the integral of which is u to the 4th over 4 from 0 to 1. Okay? We see that? U is x squared plus 1. You get u cubed du, u to the 4th over 4. Substitute in. 1 plus 1 is 2, 16. Substitute in 0, 1 to get 15 fourths. Ah, rats. 15 fourths. Okay? How are we doing? You guys doing all right? All right, we're getting there. 15. Since u form, u is 4x, du is 4 dx, multiplied by 4 and by 1/4. End up with 1/4 the integral of since u du. The integral of sinch is cosh. And that's the answer. 16. Give the integration form. What is 16? A u to the n form. Where u is the 1 minus x squared inside that square root. If you didn't have the x on top, it'd be an inverse sine form. but because you have that x, it's an inverse, it's a u to the n form. 17, inverse tangent form. 18, arc sine or inverse sine form. All right, 19 and 20, I don't know what the heck happened here. All right, radioactive decay. Here's the model we derived. Q sub naught is 10. 1% is the rate of decrease. That gives you the amount of radioactive material after any time t. We want to know how much remains after 5 years. Just multiply by 5. 10e to the we'll keep this negative going through here. E to the negative 0.05. Okay. And the half-life. Okay, to find half-life, we want to know the time it takes to go from 10 to 5 grams. Divide by 10. Take the natural log of each side. This is negative 1/100th. Okay? Multiply both sides by negative 100. Okay, and that's the answer. You all set on this? Carolina, are you all set on this? No. Oh, okay, I'm sorry. All right, how we doing? Wow, that well, huh? Well, this is all mad at me. Oh boy. All right, shoot. Okay. Let's go on. All right, question.
For 8,
8. The heck you doing back there, Sam?
I probably should have been drawing.
8, you let u equal the square root of x plus 1. That's what you got to do. Now, that's what you should do. It's possible to let u equal x plus 1 and do the problem. It is possible.
Didn't we do that in class?
You know, we did that very problem in class. We let u equal the square root of x plus 1.
I thought that was the one where you had to then manipulate the u equals x plus 1 where you get the x equals the u.
Yeah, that's exactly right. You let u equal the square root of x plus 1. U squared is x plus 1. And then solve for x and solve for dx.
If I find in my notes that we did it in class like that, do I get half credit?
No, that's how we did it in class. And that's what I want for an answer. Let u equal the square root of x plus 1. A is the answer.
Okay.
That's how I did it. Go ahead, find it in your notes. All right, that's how I did it. Okay. All right, let's start the next chapter. And chapter 7. Chapter 7's on applications of the integral. Okay? So, chapter 7. Applications of the integral. Okay. Well, the first application we have is pretty straightforward. Okay, what we already do know is this. Actually, we have some applications already. Some of the applications we already have are these.
Oh, it's bulk.
What's that?
It's taking the square root of x plus 1 and then setting the x value equal to u to then replace.
Yeah, you got to solve for x and solve for dx and do the whole works. It's a pain. Yeah. All right, some of the things we already know how to do. Given some function, let's just go over some of our applications. The area under this curve, this is fundamental. The area from a to b is the integral from a to b of the function dx. Okay? That was our problem in chapter 5. That's the problem we had to solve, was to find the area under a curve. And we solved it by using a definite integral. We did a little proof with that as well. We found average value, another application of the integral. We use the integral to solve free fall, position at any time t, by starting with the fact that acceleration due to gravity is the only force acting on this object once you throw it up in the air or drop it from some height. We took an integral to find the velocity at any time t. Oh, wait, we didn't use a vector. I'm sorry. Okay. This is Calc 3. All right. The acceleration is negative g. Okay. Sorry. We did the velocity by integrating the gravitational attraction, the force of gravity. This is a constant. We got negative gt plus a constant, and we solve for that constant. At t equals 0, the velocity is the initial velocity, v sub naught. This gives us the velocity of that object at any time t. This velocity is ds dt. By solving another differential equation, in other words, using an integral, we solve for the position at any time t by integrating this again. Getting another constant and solving for the constant. This enabled us to go from the acceleration to deriving an equation for velocity at any time t, and hence position at any time t by using integrals. Okay? Another application of the integral. We used the integral to solve some differential equations for population growth and radioactive decay as well in the last chapter. Okay? One thing we're going to be using this chapter is the fact that this area under a curve, this integral, is equal to an infinite sum. It's the limit as n goes to infinity of the sum. We saw that by dividing the area up into pieces, rectangles, then letting the number of rectangles increase. When we take the limit as the number of rectangles goes to infinity, that limit is the area under the curve, and that limit is the integral. Okay? The area under the curve, the integral, and this limit are all equal to each other. And we're going to use that in this chapter. Anytime we have a problem to solve, and we can rewrite that problem as this infinite sum, this Riemann sum. We can solve it with an integral, because if we can get it to be this sum, it's the area under some curve, and that can be done with an integral. Okay?
That's an A, not a delta.
That's an A here. Yeah, that's the area from A to B. Okay, so the first thing we're going to do is the area between two curves. Okay, this is 7.1. Is everybody okay with this? You do have the lab that's due on Friday too. Let me mention that. We have a couple people with it. One person at least has already passed it in, and it looked pretty good. All right, it was good. Basically, what I want you to do is take what I wrote, copy it, paste it somewhere else, do a couple of adjustments, change the function, change the number of rectangles, do a couple of things, and just say what happened. Okay? And that's basically it. All right?
So you won't stop us from going off on that, some crazy tangent on that?
No, if you go off and do some other stuff, you can get greater than a 90. Matter of fact, the person who did this one it was done well. They got 92. If you do the lab well and on time, you can get 92 or so. If it's a tad better, a little bit more, you get that 93. If it's really good, it'd be a 94. If I say, whoa, that is really nice, that'll be a 95. But that's about it, okay?
If we also kill one of your enemies, we can maybe get
Oh, wow, kill one of my enemies. I have no enemies, though. Really. Not that I know of, anyways.
He's
I
been
don't think
teaching
so.
a long time, people taking him up on that offer.
Yeah. Yeah. So, yeah, they would. Yeah, that's true. All right. No, that's not true. All right, Riemann sum. Okay, so let's do the first application. The first application we have is pretty simple. It's the area between two curves. This is 7-1. And one last word about the test. First test of the semester, I don't care if it's Calc 1, Calc 2, Calc 3. It must be something to do with my test. I don't know what it is, but the first test is always the lowest average score on that first test. Keep that in mind, okay? Okay, for the class anyways. Some people have nowhere else to go, but in general, for the class, it's the lowest of all the tests. It's the first test, okay? All right, area between two curves. Let's take a look. Here's the problem. Let's find the area bounded by, let's do y equals the square root of x and y equals x squared. Okay. Well, let's see what we're looking at here. Y equals the square root of x. Y equals x squared. Okay. This is the area in question. To find the area bounded by those two. Let's say this is A, this is B. In general, area from A to B bounded by the two graphs is going to be the integral from A to B. Top function minus the bottom function. Okay. It's the difference in the two functions. Why? Because if you take the area underneath the top one and subtract from it the area underneath the bottom one, the difference is the area between the two. Okay? So, by taking the area of the top one in this case, we got to find A and B. How do you find A and B? This one's easy enough to look at, but in general, to find A and B, set the two functions equal to each other to find out where these graphs intersect. Square both sides. Set it equal to 0. Factor out an x. Set each factor equal to 0, so either x is 0 or x is 1. Okay, that's where they intersect. And if you take the area under the top one minus the area under the bottom one, you're going to have the square root of x minus x squared. That's going to be integrate square root of x, integrate x squared. We're going to get 2/3 minus 1/3. Zeros give us 0, 1/3. Okay? So the area bounded by those two is 1/3 square units. Okay? Any questions on that? Keep in mind that integrals will give you negative. Everybody all set on that?
Oh, one second.
Okay, okay. Keep in mind that if you have this, let's take y equals x squared minus 1. And the question is to find the area bounded by this graph, x squared minus 1, and the x-axis. Okay? What you'd have to do is to find this point here, and actually, if that were the question, you'd have to find this. Okay? Where's the x-intercept here? Where does this cross the x-axis? Where is it? 1. And negative 1. Got an even function there. You got symmetry. If the problem is to find the area bounded by the two here, You could use the symmetry of the situation to do it this way. Sometimes it's helpful. Take twice the area from 0 to 1 of top, which is y equals 0, that's the x-axis, minus the bottom. It's always top minus bottom, okay? Okay. You with me on this? Carolina? Oh, you are? Oh, you're just tired? No? Wait, how are we doing? Are we doing okay on this? Can you see that actually? Okay. Top, y equals 0, minus bottom. All right? And I'm multiplying by 2 since we have symmetry. And it's useful to use the symmetry of the situation. So the area is 2 times the integral from 0 to 1. Opposite of x squared plus 1. X cubed over 3. Substitute in 1. You get negative 1/3 plus 1. Substitute in 0. Okay, to get 0, you're going to get 2/3, 4/3. Okay? So even though it's beneath the x-axis there, if you're taking top minus bottom.
Isn't that 2/3? Negative 1 plus 1?
All right, say that again now.
Yeah.
Negative 1/3 plus 1 is 2/3. Yes, times 2.
Oh, times 2. Oh,
Yeah,
okay.
times 2. Okay. As long as you take top minus bottom, you'll always get a positive number there. Yes?
Which one was the top?
0.
Oh.
Y equals 0. Hopefully I did that. Yes? Okay. Yes?
What happens if you replace the 0 with a negative 1?
If I replace the 0 with negative 1, I'm going to have this situation. And I want the area bounded by these two. That area is going to be 0. It's just a single point. Okay? Yes?
What happens if you have something like sine and cosine where it kind of makes, like over a certain range?
Yeah, that could have easily happened. If you've got sine x, and then you've got cosine x, okay? If that's the area in question, you're going to have to find out where they intersect, okay? They intersect at pi over 4. So you'd have to do something like sine x equals cosine x.
So would you have to, if you were doing it over like, 2 pi or something like that, would you have to do multiple and 2?
Yes. Well, no, you could use the symmetry, okay? It all depends on what you have here. Okay, 0, hold on a second. This, okay, this continues down to here. It depends on which bounded by you're going to be using. But usually it's pretty well stated. They're not going to give you a whole bunch of them. What's that?
We can't see it.
Oh, you can't see it? That's because it's probably yuck. It's probably not even right. That's why it stuck it up there. All right? So it's 0, 1, that's right. And this is 0, negative. Yeah, this is right. They intersect down here. They intersect here at pi over 4. They intersect here. 5 pi over 4 or something or other. Okay, but anyhow, yeah, you may have to do something like that. I doubt it, though. Generally, what you've got is this. This is the area in question right here. So you find out where they first intersect. Divide by cosine. That gives you sine over cosine's tangent equals 1. So x would be pi over 4. You may have to do some trig. Very elementary trig, though. Okay. May have to. Okay. Any questions? Yes?
Slightly off topic, still applies to the class. Is the homework related? Should we do later?
Oh, the homework. Did I add the homework? I didn't have the homework in that whole list. Yeah, here's the
There's
thing.
one section for chapter 6 that when I looked at it, it looked like there was like 50 questions in it, and we have until March to do it.
Wait. In chapter 6?
Yeah.
Population growth, radioactive decay?
That's what confused me, and it said I
That's
had till
confusing to
March.
me, too. Send me an email.
I'm gonna look.
There's 6.4, I think.
6.4, that's not part of our homework.
6-2.
6.2, you should only have 6.2, and it should be a radioactive decay, population growth kind of a
Exponential
problem.
growth and
Brandon,
decay.
is that what I have, Brandon?
There, yeah. But
Wait,
it's 40 questions.
Wait, 40
Yeah, but it
questions?
says it's stupid.
There's no 40 questions. What's
No,
that?
it's 40 questions.
40 questions.
6.4, we don't do 6.4.
6.2 is like.
Oh,
40 questions.
you know what it is? It's one of those the tutorial exercises.
With a population growth problem?
It's 21 points. So that's it's half of it. Look at this.
Because those mastering ones, when you have to do them, are a little agitating.
It's one of the master
Yeah.
ones. Yeah.
Efficiency
Oh
by
my
difference.
God.
Dude,
Radioactive,
If I do the
Yeah, they
practice
must be
one
easy
with the short
parts.
answers right next
I
to each,
mean,
can see
I'm
the
not
answer.
sure.
Here, I'll do it. I'll tell you how hard it
No,
is.
it can't be
I
difficult.
swear.
There's like two questions. There's a population growth question, and there's a radioactive decay question. Now, granted, that stupid radioactive decay one has like 21 parts, but I don't know, they can't be difficult, can they?
Because I didn't look at the question
Oh,
itself.
good.
I was looking at the assignments, and it gives you like the weight of every assignment that we have to take, and it was just chapter 6, and it's like 50 points, and the other ones are worth like 10 or 12, and that's why I wanted to ask.
That's a good question. I'll take a look at that. My intent was to give you like 2 questions in chapter 6. Now, if one of them has that many parts, it shouldn't be that bad.
It just makes you like enter in step by step.
What's that?
It just makes you enter in like step
Yeah,
by
it
step.
makes you enter it step by step. That's true.
And they are
It's not too bad.
very
Did you already do it?
No, I was
Oh,
looking
no.
at
Did
the
anybody
ones.
actually do it?
Well, the deadline was
I'm doing
tomorrow.
it now.
Yeah, I still
You
got.
covered it already. I mean,
I still got to finish the homework due tonight.
Didn't you do all the homework last semester?
all right.
Give us like
Yeah,
one more
didn't you
day.
do all of it like
One
before?
more day.
Today? Today?
Like at 11.
So
If you can
Wow.
push
Wow.
it,
Wait, I think I already moved that. I already moved that once, right?
Yeah, you already moved it once.
Because of the test. It's tonight. It's due tonight. I assumed, of
Just
course,
add
since your
another
test
hour.
is today,
Wait.
that you did the homework before the test. That would be the natural
Logic.
way to do it.
Well, I did.
Okay,
but-
here's the deal. Here's the deal. And this goes all the time. If you need me to move the date up, you send me an email, I will move the date up. Okay? You send me an email, I will move the date up. Okay?
Never mind. I'm just
Okay.
doing it.
Okay? That's for any of these dates, these schedules, okay? If you need me to move it up, you send me an email saying, Burns, move it up a week or something, and I will do that. For you, Carolina, I would move it to 2017. All right. Any other questions? Okay, see you.
Oh, that's it?
That's it. You're done.
Wait, Burns, we have to email individually, or you're just gonna?
No, I'm emailing me individually.
Oh, you'll move it up specifically?
Yeah, yeah. Because many people have already done it. Well, I thought you were talking about it's the homework in that list of
It's
things that
really
are going
not
to
that
drop.
bad.
The homework is in that list. I forgot about it.
Oh no, because because it doesn't. It's weird. It doesn't show how like the ones that you've done, and I knew I only had like one. Like the ones you've completed still show up as like assignments. I don't, the software has its problems. Whatever. I can
Yeah, no, I know.
And so like you can look at the score. You know, if you look at the score, obviously anything you have credit on you completed. So that's how I can tell. Like, oh, okay, I only have this one left. But then the one after is like it's 6.2, 6.4, whatever. Like 50 points.
There should not be anything on 6.4, first of all. It should only be
6.2, I'm sorry.
Okay, and it should be like 2
So
questions.
because the weird thing is that means that for the grading,
Should only
on
be
it,
2 questions.
like in terms of grading,
Yeah.
that it weighs more heavily than the entire 5th chapter.
Well, that's totally not right. All right. I'll see what I can do, something about that. That's not
Just to rehash, seriously, it doesn't matter that I was able to take the derivative. I just like I don't know. I mixed up on the form that like I get that that sine x
So what
squared.
did you put for answer?
I had sine x squared. I don't know
Is it
why
you?
I took that. I knew what I was doing with the problem itself. I just like. I guess I picked the wrong answer. You don't have
That's what
credit.
Vic said. She's like,
I studied really hard and really wanted 100.
I'll think about it. I will think about it. I will think about it.
So, doing something for tonight or March 25th, whatever it is?
Say what now?
So we're doing 6 for tonight or for March or whatever it's due for on the
Well,
site.
we've already done it.
Funny character.
I'd say do it now. I gave you those dates so it gives you plenty of time.
Yeah.
But in my opinion, you should be doing the homework when we finish it.
Yeah.
Yeah. All
I
right.
was just wondering if it's due tonight.
Well, apparently we're keeping our hands.
6-2 may be due tonight.
Because on
Maybe
the
do
thing
it.
it's due in March. So I was just making
Oh,
sure that
really?
you're not going to change it.
To tonight? No, I wouldn't change it back on anybody.
Okay.
I'd never do that. But if that one's due in March,
Yeah.
okay, good.
That was due in March, like March 24th or something.
Oh, wow. So what are these guys complaining about?
What did they do algebraically here?
Well, maybe that's what I
What's
was
that?
going
What did they do algebraically here?
It's the same thing. So you don't-
Substitute, T, what is the problem? The problem, I don't
No,
know.
it just, this turned into this, and I'm not sure how it did.
Yeah, well, I.
Oh, it's 1 over that?
What, it's 1 over what?
X3.
Still recording.